Hello everyone, welcome back to CourseSeeded. So today we are going to solve a question. Basically it has two parts. So first we'll be solving the normal part, and then we'll be solving the difficult part, I would say. So at first you have, let's define the question. So first you have a graph, or you can say grids. So let's name this the treasure hunt. The treasure hunt. So this problem is called treasure hunt. Basically I just named it myself. So you have this n cross m grid or graph, you can say, and 0 comma 1 starts from here. 0 comma 0 starts from here, from top, and at last you go to n minus 1 comma m minus 1 over here. So this is a grid of n cross m. As it starts from 0 to n minus 1, there are n rows and there are n columns, m columns. Basically it's starting from 0 and ending to m minus 1. So you have this. Let's call this. So let's define what the values would be. So let's say we have 0, 2, 3. You can take any random values. And then we can take 1, 4, minus 1, 7. Then we also have 6. Let's give a minus 1 over here so that the path is blocked. Don't worry what I'm writing right now. You don't have to worry about this. Let's block this path as well. Let's say this is 3, 2. Let's block this one as well. Yes, so this much looks good to me. So this we have 5, 4, 1. Then let's say we have 7, 8, 9. And where we can just say this is 6, 8, 9, and 2. So we have blocked multiple paths. So the question is actually that you have a grid and you want to travel from 0, 0 to n minus 1 to m minus 1. So you have to go from 0, 0 to n minus 1, m minus 1. And there you have a condition. So the first condition is you have to collect maximum treasures. Collect maximum treasures. Where you have this minus 1 means path is blocked. Path is blocked. So basically you can't travel through this grid where it is minus 1. And 0 means 0 or any basically is greater than equals to 0 means number of treasures over there on that path. Number of treasures. So you have this with you. So obviously we are not going to find the path in this question. Obviously you have one more condition. Basically you can only move right and down. This will be the part 1. Part 1. And the part 2 would be you can move up, right, left, and down. So this would be your part 2. Part 2. So let's begin with the solution. So first our goal is to find the maximum treasure from 0, 0 to n minus 1, m minus 1. And obviously we have to just travel right and down. So let's begin with the part 1 solution. Part 1 solution. So you can just, obviously for now you just already got to know that we have to use something which helps us in determining the next value. So DP is the best way for that because we are just going right and down. So DP will take care of that, basically right down, right down. So the next, basically for the next thing, DP just takes care of everything. But suppose for this question where we have to go left and up as well. So in DP you can't go left and up because it's a continuous forward movement in DP. So we can't use DP for the second part, but for first part you can obviously use the DP. If you remember what DP is, obviously it would be very easy for you. So you can go and like revise that DP section as well. So basically it is in the DSA with C++ for newbies. You'll get in that. So forget about dp right now. So we have this from 0 comma 0, we have to get to n minus 1 comma m minus 1. So obviously you have to travel either to from 0 comma 0, you can go to 0 comma 1, or you can go to 1 comma 0. So basically you can go to the first row or first column, sorry, second row or second column. Basically 0 comma 0 is our first row and first column. So you can either go down or you can go right. So let's say you want to reach at some position I comma j over here, let's say I comma j. So obviously the traversal would be similar to this. So to reach I comma j, as you can see over here, you'll be traveling either from let's mark it over here, I comma j. So to travel, so to get to this position I comma j, you'll either have to go from left. Basically this left hand side will tell you that you can go to the right side. So you can go from I minus 1 to j, or you can travel from this above this, basically the up part, which is your sorry, this would be I minus 1, not, and this would be I comma j minus 1, I comma j minus 1, and this would be I minus 1 comma j. So basically either you can go from above to down, or you can go from here to here. So with these two conditions in our hand, we can just go with our solution. So at first I would like you to determine the dp state. Obviously dpij would be your state. This will be the 2D dp. And obviously you have to find the maximum treasure. So what you can do, you can just first define that dp 0 comma 0 is the first element of your graph. So the value at this position would be your dp 0 comma 0. And then you can obviously take a for loop where basically starting from 0 and going all the way to n. And obviously you can take j as well over here. So j equals 0. And then you have this I less than n and j less than m. So with this, you can just write your next line of code. So I'm writing pseudocode over here. So you don't have to worry what I'm writing right now. It's neither C++, nor Python, nor Java. We are just writing pseudocode. So for this, you can just go if I is not equals to 0, basically I not equals to 0, or you can say just I greater than 0. And obviously your second part would be, obviously you have to check that both are not equals to 0, but this will automatically check that, so don't worry about that. So basically I is greater than 0 and dp I minus 1 and j minus 1 is not some absurd value. We can just write null over here. Obviously we won't be writing null in your actual stuff. So if this is the condition, then we can have your next part, which is going to be like determining what your dp value would be. So for this, you already know what the dp state looks like. So dp I comma j, I comma j. So if it is like, let's give it a value, let's give this some value. So let's say if there is some value which is equals to dp I minus 1 j plus your graph of this I j, so value at this position. So if this value, again we need to use this if statement. So if this value is greater than your dpij, then you can use dpij as this value, dpij as this value. So for now you might not get what I am doing, so let me just explain it in a simpler way. So your state would be for the dp, your state would be something like this. So basically you have to add this value, obviously the value at I comma j, because that would be your treasure value. If obviously this is not equals to minus 1, not equals to minus 1, because at that point you can't travel through this graph. So if it is not equals to -1, you can just go over here, and then you can also check whether your dpi -1 comma j. So basically for this also you can check this is not equals to -1 or whatever absurd value, null basically you have chosen. So if these two things are valid, so basically you'll be taking maximum of these two, dpi -1 comma j and this dpi and j -1. So as I told you that you can either travel from here or here. So this value will hold everything before this, correct? And this value would hold everything before this. So dp is your actual number of treasures till that point. It's not just on that point, but it's till that point. How to verify this? So suppose I say that this is your dp0. Let's go with this graph. So let's say we have this 0, 2, 3 and all. So basically you can just draw your graph. I have the graph directly on my side. So let me just check it from here. So this is your graph. So let's say I have this dp 0, 0, which was basically equals to your value of graph. So this is equals to 0 right now. And let's say you have dp 0, 1. That would be equal to your 2, because 2 plus 0 is just 0. And you have this 1. That would be like dp 1, 0 would be equals to, so let's do them sideways. 1, 0 would be your let's say 1. So finally you will reach at a point dp 1, 1, which will give you the summation of all the treasures before that, and you'll have to choose according to the path, basically the path which has come from above or the path which has come from left hand side, which would be the best possible path. So obviously you'll be taking the maximum value from both of them. So you'll just add this 4 plus maximum of these two, which is your 2, which is equals to 6. Now note one thing, that this dp does not care what previous values were. It just cares what the maximum value at this point was. So it just gave you the maximum value at this point instead of giving you a value which would be related to the path. So basically it's irrelevant of the path right now. So you are getting a value which is maximum at that point, irrelevant of the path. Basically path is relative, but we won't need the path, or we are not collecting that path at any place. You are getting me right? So basically that's the basic concept of 2D DP. So I think I've already taught you. This was kind of a revision for your 2D DP, I would say. Next you have your so we are over here. So why are we doing this? Why are we checking that this is not equals to null or anything? So basically it's not actually null. It's the value which you'll be defining, such as -1e9, or you can say 10 to the power -9. Sorry, not 10 to the power -9, minus 10 to the power 9. So basically this is a negative number which you are getting, which you are giving to every position of your DP. And if it is not equals to this value, that means you have already traversed through that DP, which will violate this rule. So okay, so I didn't add that rule. You can't travel the same cell again. So I forgot to mention this rule over here. So basically you can't travel the same cell again. So that's the reason I am just doing this. If it is not equals to null, it will just directly tell us that we have already traversed through this path. And obviously if value is greater than dpij, then only we take this value. Let's say if there was a value on dpij, well basically this condition most probably would never come. But let's say we add a different condition for your top or whatever it was. So let's say this was the case, j greater than 0, and obviously we are now taking dp I and j minus 1 not equals to your null. So we can all obviously do this in a single if statement, but the reason why I'm doing this in multiple statements because I also need a path. So we'll be just inserting the path whether it came from top or it came from bottom. So we'll need that path as well. So that's the reason I'm just doing this. Okay, so let me just first write the small code, then we'll be doing this complete for the path as well. So basically we are just using our brain to simplify the concepts and also get something extra from it. So we don't actually need the path, we just need what our final maximum number of treasures would be. But let's say if there was a question which gave you the path as well. So basically you can consider that this is a 4-part question. First part has 2 parts in itself, and second part will have 2 parts in itself, where we can't use dp obviously. So now you go. Now you already know what you have to use. So this is the main condition. dp I actually have written it already. So this is your main condition. dp ij equals to graph ij plus dpi maximum of dpi minus 1j and dpi j minus 1. So let's try this over here. Let me write a few things over here. First we'll need integer n comma m. Basically this would be your dimensions of your grid or graph, whatever you want to say. Let me take what all we have. So we have a complete graph to take. Okay, so it will be n cross m for integer I equals 0, I less than m, I less than m, I plus plus. Okay, so we have to define a graph as well. So vector. So we can go with vector of int. So let me first write the code so that I can explain this to you later. If it would be necessary, I'll speak. Otherwise, I'll be just writing the code. So enjoy the code right now. So this is the null value which I was talking about. So basically we can't actually define null over here because we have already taken integer over here. So I'm just giving minus 29 to this. And this is how you define an n cross m vector of this graph. So in vector you have to like define the range like this, n comma vector int m. So basically you don't have to define it like this. We are just initiating a vector inside this graph. Sorry, in a vector you have a vector. And you can't define a size of vector directly. You'll have to create a null vector or an empty vector which will be of size m. So instead of creating an empty vector, we just created a vector which has values minus 29. So every row has m columns, which is your vector, which has value minus 29. You can read it like this. So let's go to the next part. Basically taking input of the graph. Or the graph, sorry. So basically you don't need to use these values again and again. If there is just a single line after this for loop or if statement, so you can just not use these curly brackets. So we are at the scene graph. So we'll be just taking input, just how we used to take. Then we have this next thing, basically your DP part. So okay, so this is over here. So this we have to take. So let's define a DP as well. Okay, so for graph we don't need minus 29, but let's keep it like that only. Let's just define a DP similar to this. We can actually define the DP directly over here, but I would like to define it over here below the below this input of graph. Next we have our so next we can just write this in the for loop. So and okay, so first we need dp 0, 0 as well. Now let's say if the first index itself is -1, then we can't travel from 0, 0. So we'll write a condition if dp, let's take a flag, boolean flag. Basically flag is, we take flag just for the conditions which you need. There are multiple ways, but I can take flag over here. Otherwise you can just return 0 directly over here. I'll be doing by both the ways. So flag is your one. Basically 1 means that it is true for now. But if we take -1, that means, if we take 0, that means it's false. Basically invalid. Or the condition is not what we needed. So let's say dp 0 and 0. So instead of taking dp 0, 0, let's take graph. Or we can just directly do it below this, that dp part. So we have this double equals to -1. Then we can have your flag equals to -1. So we have this for int I equals 0. So let me just directly take it from here. Instead of writing it again and again, I would just copy paste it from there. So we have this I from n to m, n cross m. Then we can just remove this part and we can write our condition inside this. So let's say we have your I greater than 0 and okay, so we don't have to write it like this. That is for the path. Since we are not doing the path part, I would recommend you to do the part for this question. That would just increase your mental thinking, I would say. So we just need to write this dpij is basically equals to your graph I and then j. There's one more condition, if I double equals to 0 and your graph double equals to 0, or we can say sorry, not graph, j, it has to be j. So if I double equals to 0, basically if I has a value of 0 or j has a value of 0, then we can just continue and we can just write dp over here after this. So basically 0, 0 we already took the graph of the 0, 0. So now let's say if I take I remove this condition, then it would be problem for our dp because we are going to add maximum of dp I -1. So this I -1 would go like dp of -1 if I was equals to 1 or j was equal to 1. So that's the problem we would face in our whatever this is. So we have this dp I -1 and then j comma dp of I comma j -1. But there is also a possibility that only I is 0 and j is 1. So at that time also we'll get some absurd value over here. So for that I think it would be good to take if condition instead of directly doing it like this. Yes, so if condition would be still better to use than using this. There's one more condition, if graph of ij, if graph I and then j double equals to -1, then also we continue. Basically we can't choose any path. Let's see if we get it directly over here, otherwise we'll be just implementing these conditions. So if I greater than 0 or I not equals to 0, because over here we don't have any negative index. So yes, if I not equals to 0, then we can have this condition. So just wait, right? And if we have obviously dp I minus 1 and j not equals to your basically not equals to your minus 29. I hope we took minus 189 over here. Yes, so we took minus 29 for your dp. Then we can just remove this max part and we can just do if. So instead of doing max of dp I minus 1j, we'll be just doing dp ij and this. So we won't be checking both, but we'll be checking this at least. Sorry, not this. Basically max of this. This, comma this. So I can remove this max part. Let's remove this. And then we can type max over here. So basically what I'm doing, I'll be just explaining in a few seconds. So basically we are just taking this graph ij and dp in the previous one and the current dp, whichever it is. So why the current dp? Because in this next if condition, we would need the same values. So basically whichever would be maximum between them, it will automatically give us this value. As you can directly see, I'm just doing maximum of graph this and graph ij, and then maximum of graph this and graph ij. Sorry, dpij. So it will just give us this condition automatically. You can try doing the maths over here, but I'm not going to explain everything. Basically, math is your part. I would recommend you to at least solve this much of math. Because we have already done calculus and all, so it should be a piece of cake by now. And we can just add the same condition over here. Notice that you'll have to change your change this as well, I minus 1. Instead we will be doing j minus 1. Yes, so finally it looks good. Yes, so everything looks good. And we have this for loop. Let's see out dp. So if flag is, obviously we have to do one more thing, dp n minus 1 and then m minus 1. So we can write this condition if dp n minus 1 m minus 1 is not equal, sorry, is double equals to minus 29, then we have our flag as minus 1. That means we never reach this place. So we had to reach n minus 1 m minus 1, but if we still have this minus of 1e9, basically minus of 10 to the power 9, then we can just leave that. So let's see out the rest of the part. So if flag double equals to minus 1, let's see out no path exists. No path exists. Otherwise we can see out. But not minus 1, we have to take 0. Or we can just remove this. Or we can just take this as integer. That won't be a problem at all. Yes. So if flag is equal to minus 1, otherwise see out this. See out. We can just see out dp n minus 1 and n minus 1. So let's check whether there are any problems or not. Suppose if your answer is 40 something 9, I think, then it should be good. So let's try that now. Let's take the input for now. We didn't got any errors, I would say. Sorry, we didn't get any errors. So that means we must have done everything correct. But still there can be logic error. So it's 52 currently. I think the answer should be 49 instead of 50, whatever it is. So let's check why this is happening. Graph of ij plus dp I comma j minus 1 comma this maximum. So basically this part is correct for now. Let me just check. Let's say we go right Okay, so let me draw it over here. So let's say we have this 0, 2, 3, -1, 5. You can take random values as well. Basically check for all the edge cases. Basically -1 over here, otherwise -1 and -1 over here. So that will also block the path. Then we have 4. Then we have -1. Then we have 7, 6. Let me just remember everything. -1, 8, 9. Yes. So we have this 0, 2, 3, -1, 5, and 1, -1, 3, 2, and all 4, 8, -1, 6, 1, -1, 9, 5, 7, 7, 2, 4, 8, and then 6, -1, 1, and 9. So we have all this. Then we have this path. We'll go from 0 to 2, then 4. Then we'll travel. We can't go right. Let's draw smaller arrows. So we have 0 to 4, 2 to 4. Then we have 8. Then we have 9. Obviously, you can travel 2 and then 4 and then 8. But 5, 7 is better because it gives more treasures. So we have 5 and 7. Then we have 8 and 9. Obviously, you can't go up in our first part. It says completely like right and down. So you have this path covered. So let's add them. 2 plus 4, basically 6 plus 8, 14. Then you have this 23. Then you have this 5, 28. Then you have 35. Then you have 17 to add, which would be, I think, 52. Yes, so 52 is correct. Sorry, it was my bad that I miscalculated earlier. So 52 is actually correct. So we have the correct path and correct everything. Now let's talk about the path, how you would think of the path, I would say. So obviously you can take the path or parent like from where you came, right? So you will create a parent vector where you'll be checking whether you came from you came from left or you came from top. Basically you're allowed to go right and you're allowed to go down. So you'll be checking you came from left, basically you came from this side or you came from top. So that is the basic ideology. So let's write the code for that as well. So obviously you have everything ready. Basically these two where is it? So basically these two if conditions are useful in that case. Let's just define a vector. Obviously you can put comma over here and define it over here, but since it is getting out of my writing area, I would define it below this. So we have the same comma -1. You can define everything in a single line. That won't be a problem at all. So you have all this. And next you have your parent over here. So we can just write parent. And then the parent would look like, obviously you'll have to check one more thing. Let's say if this was like your dpij was better than your this part. So if dpij remains unchanged, then you don't have to like write anything. So let's calculate a value if int value equals to dpij. So if the dp value changed, then only you have to take that insertion in the parent, basically that as the path. If suppose this dp didn't change, if dpij equals to state this was the maximum path, this was the maximum point, then the path won't change. So that means you don't have to write anything in the parent. So let's define what we'll be introducing this and this as. So basically if it comes from left, let's say it is 1. If it comes from up, then let's say it is 0. Or yes, so let's say it's 0. And if it was -1, then you already know what it is. Basically it's a cross. Basically we never travel there. So you have int value equals to this. So let's say if value is not equals to dpij, Then you can have your parent, parent I comma j. Okay, so parent ij equal to, let's say, which was this, I minus 1. Basically, it was the left one, so we'll just define it as 1. Obviously, we won't be able to do the second part, or I would say left, right, up, down part in this lecture, because I think so we have already passed 35 minutes, and that is actually a large question, I would say, large part. So it will at least take 1 hour. So let's do that tomorrow. So tomorrow also you'll be getting a lecture that is on Saturday. So basically I'll be creating the lecture today, but you'll get that tomorrow directly. So you have your same thing to be done over here. So let's call this, and let's call this over here directly. Only over here you'll have your 0 directly over here. Since we have all this, we won't be doing any changes over here. We'll just go to check what our parent is, or what our parent looks like. For auto, vector into parents, so vector s to parent. Let's say we have for auto node s to vector. We can have, okay, so instead of, oh, this looks good to me. Cout, cout the value which is your node, and then we can have this. Then we can cout end line. So basically, cout end line would help us to like differentiate which row and column are, sorry, which row it is. I think it's good. We can just cout one more thing. Cout. Okay, so we have to path exited, and obviously slash and over here. Let's try this with the same input, I would say. So we have, okay, so we have first path has -1. So yes, I forgot to tell you this. So basically we are not going with 0 and 0. So we'll just have to give this as the path. Let's say if flag was not equals to -1, only then we can give it the path. So let's say if flag not equals to -1, and obviously if flag is not equals to -1, then only we do all this. Sorry. Then we can just have your all this inside that. And obviously you'll have your parent 0, 0, 0 and 0 equals to your this. Let me check what it should be. Okay, so let's keep it -1 only for the obvious reason. Well, or you can just give it 2 instead of -1 or anything else. So 0, 0 is your parent, which will be your 2 instead, because we are not traveling anywhere to this point, because no nodes can be traveled again. And also there is a condition that we can't go left or up. So obviously we can't go to the same path, sorry, the same segment. So basically this condition is useless right now. This, you cannot travel the same cell again. Because we are just going right and down, so we eventually can never go to the same this. We eventually can never go to this same stuff, same cell, I would say. So yes, so finally you have the answer, and I will just paste the input over here. So Okay, I added this instead of adding that. We just copied that from there to there. So let's just see out. Yes, so we have this 0, 2, 0, 0, and then 1, 1. Then we have 1 over here, and then we have this 1 over here, and then we have 1 over here. So we can do two things right now. Basically, since we have the path, so we can either directly do it from here, that we came from top or left. So we can create a vector. So instead of taking a parent complete, what we can do, let me just write it over here. So let me just check what the maximum path would be. So it would be like, so actually there won't be any maximum path. There will be exact number of steps, which would equals to your n cross m. Why? Because let me just tell you one thing. So basically, if you're traveling somewhere in a small grid, let's say, and this is your grid, so you'll just have to travel 1, 2, 3, 1, 2, which is your 5 times. And let's say you travel this 1, 2, 1, 2, 3. This is again 5 times. Let's say you travel like this 1, 2, 3, 4, and this is again 5 times. Let's say 1, 2, then 3, then 4, then 5. So to travel from here to here, you'll always have the same number of, you'll have to always travel the same number of cells. So it doesn't matter anything. So in this case, we don't need to take any parent right now, but yes, it's a good practice to take that as well. So we can just directly take vector int path n cross m. But yes, in our next question, we'll be doing it by the parent method, because that's the original method, I would say. Or for these type of question, we use that only. So we have this n cross m. And then you can obviously have your own logic over here. So if value is not equals to dp, then we can have your, let me just do this. So you have this. So it matters where we are traveling. So let's say, then we can have your path I cross j, I times j equals to, let's say we take character instead of integer. So this will be the path. So for this, we are going to the right, I think. Where it is? Yes, so it is over here. I minus 1. So we are going to, we are going down in this. Okay, so I think the 1 was for down, not for that. Basically, I minus 1 is your, so we have this. I minus 1 to I, basically I minus 1 is above this, and I is over here. And j minus 1 is over here, and so basically you could have just seen it from here. Okay, so here, basically I minus 1 is above this, and we are going down. So basically this is from up down. Anyways, so we have path I times j as your down. Okay, so there would be only this n times m minus 1. Basically first and last won't take any paths. So you just have to find the paths in between them. So this would be like 3 times 3, which is your, 1, 2, 3, 4. Okay, so n minus 1 times m minus 1, I would say. Yes. So let me just check whether it is n minus 1 or n minus 1. So let's say we just have this. This is your 3 times 2, which is your 6, minus 1 equals to 5. 1, 2, 3. Okay, so if we go with 2 times this one, that would be 2 plus 1. Okay, so we need 3 paths. Let's try it with your 3 times 3. So 1, 2, 3 4, which would be like 2 times 2, but it is actually getting equals to 2. Okay, so basically minus 1 times you have to travel this, and minus 1 times you have to travel this. Okay, so it will be addition, not multiplication, I would say. Basically n minus 1 plus m minus 1, it won't be multiplying that because that will just give us grids instead of giving us the number of paths we need to travel. So it was my mistake, a calculation error from my side. So you have this, then obviously you will be doing I plus j over here. Let's say where we are needed to go. So basically path 1 would be your downward right. Okay, so no, this actually might be a problem. Let's say we are over here and we are over here. Then if we travel this and this and this, and if we travel this and this, and over here we are just going from this path instead of going from this path, then obviously you can't just take a left, right. Basically this DP would just give every path from here to here, and this DP would give every path from here to here. Okay, so we can't take the path method, so we'll have to go with the parent method only. So yes, our parent method stays as the best method right now as well. So yes, the parent method is the best way. So let's remove this. Basically we don't need any extra lines. Yes, so obviously you got the parent, then we can just write integer I equals 0, and then we have your j equals to 0. Sorry, not 0. Basically we are going from reverse order. Now we'll be tracing it from here to here where we traveled. So we'll be going with n minus 1 and m minus 1 over here. So we have this, and then we can just do while I not equals to 0 and j not equals to 0. While these both of them are not equals to 0, we'll just have your this parent guide us from where we are going. So basically if this was this. Also we had to travel more over this side, and we can't just go up over here. So basically this 0 tells us that we have come from right instead of going from there. So in this case we can have like multiple paths as well. We can create multiple vectors of path, and then we can collect all the paths, and whichever would be like the best one, we can just add that. But I won't be doing it like that, because that will be like the time of complexity would be, it will actually go in factorial. So that would be bad, I would say. So let's try to think of a method. So basically till this, this is 0 and this is 1. So let's say if parent 3 comma 3 was your 1, parent 3 and 3 was equals to 1, which is, I think, 0 1 2 3, and then we have 0 1 2 3. Yes, so it is 1 over here. So what you can do, you can just say that 3 comma 2 was the original path from where it came. So basically traversing from reverse side is very good, because this will just keep telling you from where you came to this point. So if this was 1, then it gave you that we came from 3 comma 2 instead of coming from 2 comma 3. So that's the reason we are going from this down to up. So yes, we can do it that way. So we just need to write the condition. So that would be like, obviously if you have that, basically if you have okay, so let me just write if, so we can just have this path, basically path. Okay, so we didn't have any path over here. So let's write vector in path. This path is actually different than what we were trying to do directly. So this is the path. Let's say we have a string instead of path character over here. That would be like n plus m, I would say. Yes. So path I comma j. Okay, so it won't be I comma j. Instead, it would be I plus j, I think. So we are not directly doing path. Let me just think for now. So let's say we have this. So there would be condition, right? Let me just think over here. So if it is 1, then we take the path as, sorry, if this is 1, then we take the path as this left. Otherwise, we take the path as this up. Yes. So we have like 1 as your, where is it? 1 as your up and, sorry, down, and 0 as your right. So if parent, if parent I comma j, if parent I comma j, or we can take pair of int, which will just give us the path, but we don't need that, I think. So if parent I comma j is equal to, sorry, why did I write I comma j? So we have this parent I comma j equals to your double equals actually. If this equals to your 1, then you can have top right. So write cout. Actually, we can just cout directly, but let's try taking this in the path. So path I plus j, or we can have, yes, so this looks good. So path I plus j, it would be like up, right, sorry, down. So basically we'll be just reversing everything when the time comes. So we'll just reverse the whole path, which will give us the correct order. Else we have your, sorry, not else if parent I and then j. So else if parent ij is as your if parent ij double equals to your 0, then you have path has path I plus j as your this. Let me see. So we have this path I comma j as your this. What was 0 again? It was right. And we need a string and stuff. What am I doing right now? Okay, so I'm actually doing very normal errors, I would say. So we need a string, but I'm just writing it as a variable for some reason, I don't know. Okay, so we have this. And then we can have your this next thing, which is your path I plus j equals to down and path I plus j equals to your right. Then you have your this, the second thing, which is your, let's say you have the last thing, which would be, yes, so we have to change I and j as well. Let me just check it over here. This was coming from up, so it was I minus 1. Okay, so I minus equals to 1 over here if we are coming down, and this is j minus equals to 1. So that is, yes, so that looks perfect right now. So I hope this is correct. Well, actually it looks good, I would say. Well, basically till this everything is correct. We just have to think of this. Then we can just have your cout and L. Okay, so I am not giving any space. That's a problem. Okay, so sorry. We don't have to give any space because that's getting inside the vector. I thought I'm just taking it as an output. So yes, this looks good. We can just have your output right now after this. So for int I equals 0. Yes, then. Okay, so since there might be a problem that it might go into an infinite loop. Basically, if the flag is not equals to this minus 1, sorry, if the flag is minus 1, so we'll just include everything inside a minus 1 flag. So let's remove this, and inside this we can just have a space over here, and then we just have this. Yes, so it looks good. or we can just directly do it inside this else. Basically it is not equal to -1 only. So let's go over here. Instead of going it like this, we can just have it. Yes. So everything looks perfect right now. So let's say I less than path dot size. Well, obviously you can write n plus m, I plus plus. And then you have, okay, so let me just give it some different a string if that's the case. So we can have this. So basically it will have this O symbol if we have done any error. So at that point it will just give us this. So we have this I0, I less than path dot size, I plus plus, and then we can just have cout path I. Okay, so we have completed everything. Let's just take the input over here. And then we can have it as the output. Path exited. So we have down, down, right, down, down, right, right. So let's see. Down. Okay. Okay, sorry. So we have to just reverse this instead of because we took it from n-1 to m-1 to 0. So we have to reverse this. Either we can just directly reverse it over here. Reverse path dot size. Sorry, path dot begin. Path dot begin. Path dot end. So either we can directly reverse this, or we can just have this in the reverse order. Basically, I equals to path dot size -1, and then I greater than equals to 0, I minus minus. So both the ways are correct. So we finally got the path as well. Basically, we are going to right, and then we are going to right. Okay, so that's actually wrong. We had to go just a single right, and then we had to go down. Let me check what we have done wrong. So if parent is basically 1, so let me check one more thing. So if we were at I minus 1, then we were supposed to go down, and 1 means down, and 1 over here means down. Yes, so it looks good to me right now. Okay. So we just had, okay. Just don't worry about this. I'll be just doing this cout I less than this. So we don't need to do that. So basically I plus j equals to 0 over here, and then I plus j equals to this right over here. So we are going to right, and then we should go down by official logic. So we are going right, down, down, right, down, down, which is completely wrong. So 2 rights, 3 rights, and 3 downs. That's actually correct. 3 rights and 3 downs. Let me just check it over here. So we have 0, 1. So let me check. 0 means coming from left. 0 means coming from left, then coming from up, then coming from up, then coming from left, then coming from up, then coming from up, then coming from left. So by this, we are actually getting everything correct. Basically, till this it is correct, but this right, down, down is wrong. So let me just check it over here. So if, else if. Okay. So if I not equals to 0, j not equals to 0. So so let's first write this in the normal order, what we are getting. So let's write this up, and let's write this left. And then let's make this like this, and then we have got this. Then we have got this. So basically it is like going up. Where is our array? So basically going up instead of left. Okay, so we did something wrong over here. Basically if parent ij equals to 1, then we are supposed to come from up, right? Sorry, we have to go up. So this is correct, but I'm actually getting confused right now. Let's just write left for no reason, I would say. And let's write above error. Basically, I'm just glitching out, I think. Okay, so this is left, left, up, up, up. So let's check. Left, left, up, and then up. Okay, so sorry. Left, left, and then up, then left. Okay. So what can I say? So parent ij equals to 1, and then we have to go left for no reason. So 0 means left, right? So 0 means left, but okay, so 0 means left, but we are getting at 0, at the 0, n minus 1, n minus 1, we are getting our left. Well, why is this happening? Why? Let me just first check one more thing. Why is the Let me just check one more thing. Let's, instead of doing this, we are just going with our this loop. Instead of using auto, we are going with this. Just this. Then see out parent, I think. Parent I, j. And then we're gonna have this. And then we're gonna have see out angle. C in. Okay, sorry. Basically, while I copied that, I just didn't change C out. Wow, while I just copied that, I didn't take the input again. It's not run yet. Yes, so we can finally run this. So we got this, which is your completely perfect thing. So for some reason we are just getting wrong for this path. Let's see what we are getting wrong. So let me just change this. Let's say we have this vector of end, or we can just keep it like this. Left, left, up, left, left, up, up. So this we are not getting anything, right? Oh, okay. So basically, our path starts from 1, I would say. Basically, it starts from here instead of starting from here, and we are leaving I as 0 and j as 0. So we are leaving that, and we are leaving also this, either I as 1 or j as 1. So we are not getting this path first, which would be like up or left, whatever it is. So okay, so I finally got it. So basically everything was correct. Let's say this was up, this was left. So basically, let me just change this. And also we are getting some wrong paths, I would say. Basically this was supposed to go from 0 to left. So we are just getting left. Okay, so we are getting right. Left, left. Then it should go up. Then it should again go up. Then it should go left. So basically this we are getting wrong. Let's see why. So instead of doing everything like this, I plus m. Let's change the tactic. Let's say this. Let's say this. Well, actually, it's not going to change anything, but yeah, let's try this. So we are getting everything a direction more than what we need. Okay. So instead of taking this, let's take vector int. Vector of int. We can, sorry, instead of taking vector of vector, we can take pair int command. And we can just have your path. Let's say we don't define the path right now, because defining the size of that is actually giving me a headache. Then we have this path dot pushback I comma j. Then we have this. Okay, so instead we will be just taking a single output, I would say. And then we can just remove this as well. Or we can just keep them. We can just mark them as this. And then over here we just have for. Obviously we'll have reverse as well. Let's see what we are getting right now. So basically the path is reversed. Now we have this for int. Okay, so for integer, or we can just take auto instead of integer. Auto x comma y s to this path. Let's see out the path. Sorry, we don't have to see out path. Instead we can see out x, and then we can see out y over here. Then we have our this see out in nil, which is perfect. Okay, so instead we have to write this. Let's try this. And okay, so we are getting some errors. Okay, sorry. So it'll have this curly brackets as well, because we took pair instead of because there are two values, so we have to take it like that. So obviously now we are done with the debugging, I think, but obviously I'll try to correct that in the next lecture as well. So let's try this. So path, okay, so I didn't save it or what? So path dot pushback I comma j. Okay, so we finally got everything correct. Basically I forgot to save that. So we have this 1 comma 1, which is completely wrong, I would say. So yes. Okay, so let's think that it came. So basically it's skipping it. Just skipped two of those things. Basically any of them. So basically we were supposed to cross this if both were not equals to 0. Oh, sorry. If both were equals to 0. No. Sorry. So if both were not equal to 0, then only we were supposed to do this. So yes. Now I get it what I was doing wrong. So while true, I would say. So we have if I not equals to 0, j not. Basically it's writing the same thing, but I don't know why this would help. It's just my sense which is telling me that it would help me. So we have this. While both are not equals to 0, then we can just have this. Cout nl. So we don't need this or what? Okay. We don't need this. So we have this reverse and all. So basically else, and then this is the last part. Let's see if we are getting at 64th line. So what's the problem over here? While true this, else while this, okay. Oh, sorry, I got it. Yes, so finally it's correct. Yes, so we got it. Let's see if we are getting the correct answer or not. Okay. Path what? Why is it asking for input? I don't know. Let's see why it is asking for an input. So basically, actually I don't get it at all. Let's say 12. Okay, so I got it finally. Basically, it's just stuck in the while loop forever. I didn't break the while loop for no reason, I would say. So why while I double equals to 0 and j double equals to 0, we can break this, and then we don't need this, and then we can just have our same stuff again and again. So we have this. Let's try to stop this, and then let's have your input, and then we have the path 0 1, and which was yes. So finally we are getting it correct. So obviously we are not going to get anything. So yes. Sorry, I was shouting. So we got the answer, I think. Let's see whether the answer is correct or not. So where's our graph? So we have this graph which we are going from 0 1 and then 1 1. Then this is your 1 comma. Sorry. Yes. So 2 comma 1. So let me write the path itself. If we have graph anywhere else, yes, we have this. So at first you have, okay, so we will just not write 0 comma 0. Basically you can just push back this 0 comma 0 over here. Let me just push back. Sorry, push front instead. So push front 0 comma 0. Or we can just, instead of pushing front, we can just push back over here. Path dot push back. We'll just be doing 0 comma 0, and I think we got the final answer. So let's directly do this. Yes. Yes, so we got 0 comma 0, 0 comma 1, and then all this till 4 comma 4. So let's see how many are there. 1 2 3 4 5 6 7 8 9. Yes, so finally we got the correct answer, which will be your, I think, 9 only. 1 2 3 4 5 6 7 8 9. Yes. 1 2 3 4 5 6 7 8. Oh, okay, so we are going to get 8, but we are getting 9. Okay, so we don't need the 0 comma 0. Sorry, we are getting cells instead of path. So we got everything, I think. So we got this from 1 2 3 4 5 6 7 8 9. So we got all the 9 cells, and the path 8, the path would be 8. So it's perfect. So let's just verify this one last time, whether it is correct or not. And I'll be giving you a recap right after this. So basically what we did, let me just first give the recap. So what we did, we just took something from 0 comma 0 to n comma 1. So we had the choice to go down or right. So we just took that in our mind, and we just solved whether we can come from up or we can come from left. So that was the whole point behind this. And then we took these conditions, which you already know. So we just have to find what logic we are going to use, which will help us the best. So we just did that, and we got everything correct. So let's verify this. We have this 0 comma 0, and from 0 comma 0 you have to go to 0 comma 1. Basically this path is over here, so you can just match this. Or then we go from this to 1 comma 1, then we go from here to here, which is your 1 comma 2. Sorry, not 1 comma 2, 2 comma 1. Then you go from there to your right side, which will be your 2,2. So then from there you will be going from 2,2 to this downwards, which will be your 3,2. Then you'll be going down again 4,2. Then you'll be going at the right side, which will be your 4,3. Then you'll be going down, right again, which will be your 4,4. So we got everything correct. Thank you, and thank you everyone. Thank you for joining. So let's meet for the next part tomorrow. So please be ready for tomorrow as well, which is your Saturday. So tomorrow we'll be solving the next part of this question, which is left, right, up and down, which will not require DP because DP cannot be used there. So think carefully what you can use and write that in the comment what we are going to use. And if you have the solution, then you can post that as well. Thank you everyone. Thank you for joining. Let's meet tomorrow.